folks, and welcome back. In this video we're going to discuss battery testing and battery charging. Okay, so as far as battery testing goes, there's a few different things that you need to test a battery for. We can do a battery state of charge test. We can do a battery capacity test. And we can even do a battery drain test. Okay, so for the first one, we're going to start with battery state of charge. And basically all we need to do this is a multimeter. We're going to look at what's known as open circuit voltage. So open circuit means that you don't have anything in the vehicle turned on. The best way to do this would be disconnect the battery, but it's not necessary as long as you're sure that there's no electrical loads on. So the door's closed, the dome light's not on, the key's not on, there's no under hood light on. And when you're checking the open circuit voltage, it's actually very sensitive. A little means a lot. We hook up our meter. We set our meter to DC volts. We put negative on negative, or black lead on negative. We put the red lead on positive, and we look at the voltage. A fully charged 12-volt car battery is going to read 12.68 volts or higher. That doesn't necessarily mean the battery is any good. This is not checking battery capacity. This doesn't tell us anything about the electrical system in the car. It just tells us, is this battery charged or not? And it's pretty sensitive. If this drops down to 12.45, that's 75%. If it drops down to 12.25, that's 50%. If it drops down to 12.05, that's 25%. And 11.85, basically, it's dead. It's dead. So despite this being a 12-volt battery, we call it a 12-volt battery, really it's 12.68 volts open circuit if it's fully charged. So the two numbers you really kind of need to memorize the most, obviously, would be the 12.6 or the 12.68 and the 12.45, and there's a reason for that. During our next test, our battery capacity test, depending on the type of testing equipment we use, we need to make sure the battery is at least 75% charged before we do the test. If it's not, the test is going to be inaccurate. So, open circuit voltage can at least tell you if the battery is charged. Just please know that it's not going to tell you if the battery is any good. Alright, so for battery capacity, we have a couple of options. Battery capacity is going to determine how many amps this battery can deliver, and there's a couple of different ways of doing this test. The modern test is what they call an impedance test. And the reason this is preferable is our little modern impedance testers are small, handheld devices, a couple of small cables hook them up. It looks kind of like a voltmeter. Usually has a little printer built into it so that you can print out a little results slip and staple that to a repair order. But it doesn't load the battery. It doesn't beat the battery up in any way or do anything aggressive to the battery. And it's very simple. It's very straightforward. There's a little digital screen. There's some buttons on it. It's very self-explanatory. You hook up the red lead to the positive, the black lead to the negative. You follow the prompts on the screen. It runs a test. It gives you results. It's favored by all the OEMs. This is the type of tester they want you to use for warranty work. It's the type of tester that they're going to take out at AutoZone or Advanced Auto Parts or wherever you go, whatever auto parts store you go to where they come out and as a courtesy test your battery, they're going to bring out an impedance tester. The only problem here is I don't own an impedance tester, so I can't demonstrate one for you, but I do own a regular load tester, which is the older test. And it's a little bit more aggressive. demonstrate that for you in just a moment here. The way that that's going to work is you're going to hook the battery up to the load tester. This is a much bigger piece of test equipment. The ones in shops are big, large rolling things with wheels. There's the wheels. It's usually a handle up top. There's going to be a couple of needles on it, a couple of meters. Some of them are digital. I prefer the good old-fashioned analog ones with needles. There's going to be a big load knob on there and some really big cables, big clamps coming out. So, big alligator clamps. Oops. Big heavy cables. And the reason everything's big cables, big clamps, is because we're going to flow big current with this machine. So I'm going to demonstrate this for you in just a moment. The procedure goes a little bit like this. For a load test, or what they call a heavy load test, we are going to connect the tester. We're going to make sure that we have 12.45 volts or higher before we start. We're going to dial up the amps on this machine to half of the cranking amp rating, or the cold cranking amp rating, for 15 seconds. So if this is a 600 cold cranking amp battery, we're actually going to turn this knob up until the meter reads 300 amps. So to be flowing 300 amps through these cables, obviously they have to be pretty big cables, and obviously we're going to be stressing this battery out, and we're going to do this for 15 seconds. While we're doing this, we're going to watch the voltage, and we're going to see what happens. So when we first hook up, the voltage should be, again, at least 12.45. Once we start flowing 300 amps, the voltage is going to drop, and it's going to continually drop throughout the test. At the end of the test, which is 15 seconds, it can't be any lower than 9.6 volts. If it is, the battery fails. So, must maintain 9.6 volts or higher. A couple of batteries here on the bench that you can't see with the camera angle right now that we can load test, and we'll see if they pass. So this test has kind of fallen out of favor. One, it's more dangerous. It stresses the batteries out, so it can cause them to heat up and swell and release gases. It can cause the tester itself to release a lot of heat. You can make sparks at the terminals. So it's a little more of a dangerous test, and for that reason the manufacturers don't prefer it. When the battery is hidden somewhere in the car, you can't do this test from the little jump start ports points that they give you up under the hood, because of the serious amount of current you'd be flowing through all of that wiring, and it's not meant to carry all that much current. So you have to go right to the battery, and it's just a lot of stress to put on the battery and the electrical system and the tester itself. So it's kind of the less preferred test, although I actually like it because I get to see what exactly does the battery do under load, under strain. So we'll demonstrate that in just a moment here. Another test we can do on the battery, actually two tests we can do on the battery, as long as we have our multimeter. And again, I'll demonstrate these for you as well. I can hook my multimeter up to only one post. In this case, it'll be negative. And I can search around on the top of the battery case, not actually touching the other post, with the red lead, and see if it reads any voltage. If it does, that's telling me there's conductive electrolyte on top of that battery, and that's causing a discharge. So if that happens, you simply need to clean the battery. But if you don't, what's happening is the battery is discharging itself through that little film of electrolyte, because remember, electrolyte is conductive. So we call that a surface discharge test. You're just trying to measure for voltage. On the top of the battery case. The next thing you can do, if you've got a battery that repeatedly goes dead and you suspect that there might be a load in the car that stays on or comes on and drains the battery down, they call it a parasitic draw. So something like a parasite taking from its host. So like perhaps a glove box light that never turns out, a trunk light that doesn't turn out, an electronic module that's beginning to go bad and there's something wrong internally with it, drawing current all the time. So your red cable, as you know, goes off to the vehicle's electrical system. Black cable, as you know, goes to ground. As we've mentioned in a previous video, it's safer to connect and disconnect the negative side because that's the ground side. We're going to take our multimeter and get it set up and ready. We're going to set it to amps. We're going to connect our black lead to the negative post on the battery. We're going to connect our red lead to the negative cable after we disconnect it. And basically what we've done is we've put our ammeter in series. So ammeters go in series. They work almost like a water meter in the basement of your home if you have town water supplied. The pipe comes in, it passes through a meter, and then continues on its way. Similar also to a power meter on the side of your house. The high current cable comes in the top, goes through the meter, goes out the bottom. So this meter is in series, and this is going to tell us if we have any kind of parasitic amperage draw. So anywhere from about 10 to 20 milliamps is considered normal. So that would be expressed as 0.010, 0.020 amps. Okay, that's considered normal. Much above that, and that is kind of considered a parasitic draw. Maybe it's normal for the vehicle. There are some vehicles that are known to have a pretty high ignition off or key off draw, meaning the current that flows all the time is kind of high. It could be normal for that vehicle, but it's probably not. This, unfortunately, is not necessarily a spec the manufacturer is going to give you. They don't always tell you what is an acceptable amount for a parasitic draw, so you kind of have to go by just general rule of thumb. I like to see in the 10 to 20 milliamp range, and that's about as much as you really want. If you're seeing a quarter of an amp, that's a tiny light bulb left on somewhere, or a module that's going bad. If you're seeing a half an amp, there's something serious going on there. Basically, what you would have to do then is one by one remove fuses from the fuse panel and try to isolate which circuit is drawing the current. When the reading disappears, you know you found the circuit that's causing it. So it's a trial and error thing. Fortunately, it's not something that happens that often. In my time in the field, I only had to diagnose a small handful of cars that had parasitic draws, and at least one of them was customer installed equipment. There was a mag light charger that was in the vehicle, and it was the light itself. If you took the mag light out of its charger, the draw went away. So in that case, it was a customer issue. But improperly installed stereo amplifiers can do it. Aftermarket alarms and remote starters that are on the fritz can do it. So there's a few different things that can cause it. So I can't really adequately demonstrate this without a vehicle in front of me, but I can kind of show you how it's done here on the bench in just a moment. And then the last thing for the board, while I have you up here, before we move the camera to the bench, is charging. Now, the slower you can charge a battery, the better. The faster you charge it, the more amps you force into it, the more heat you build up inside the battery, and basically the more you beat up on the plates inside the battery. Alright, so slow charging would be considered 10 amps or less being forced back into that battery by the charger. If you get down below an amp, that's known as a trickle charge. It's going to take a very long time to charge a battery at 1 amp or less, but it is considered the best way to charge a battery. In the real world, when we're working in the field, we don't have that kind of time on our hands. If If a vehicle's got a weak battery, we can set it up on a 10 amp charge and we can kind of leave it alone for a couple hours as long as we're not leaving the area in case something should happen. You never want to leave a battery unattended on a charger, but a few hours at 10 amps will probably get it up to where it needs to be. If you're in more of a hurry, you can crank it up to 20 or 30 amps or even higher if the charger allows it. And it will charge the battery faster at the expense of beating up on the battery's plates a little bit. So if you left the brake pedal depressor on when you were doing an alignment and then you went to lunch and you came back an hour later and the car didn't want to start, customer wants their car back, you're probably going to be hooking it up to a fast charger and trying to get some charge in that vehicle before you let it go. It would be rather unprofessional and very bad practice to just jump start the car and give it back to the customer immediately. You never know if a customer takes their vehicle from your shop and goes 5 minutes down the road to the convenience store and shuts it off and goes inside. Maybe it hasn't had enough time to charge back up, and when they come out, they've got a dead battery or a battery that's not strong enough to start the car. So that's a problem. But slow is better. Never leave a battery charger unattended, even if it is a slow charger. A trickle charger, on the other hand, you can actually leave these unattended because trickle chargers have circuitry inside them that will make them shut off when the proper charge is attained. So again, I'll show you one of these. I have one on the bench here. Okay, so I need to move this camera. I'm going to bring it down here. Get to see a little bit of my makeshift bench here, my folding table set up in my garage just for this. So we have my trusty multimeter. We're going to be using that in just a moment. Our heavy load tester right there. Demonstrate that. I have my Napa by Midtronics trickle charger. So basically, it's a little power supply here. It's like a wall wart. This plugs in. It's got a nice long cord on it. The other end's got alligator leads. It also comes with a set of leads that you can hook directly up to the battery with ring terminals. And midway in the cord, there's a little two-prong plug, so you can leave a piece of it attached to your vehicle. I have one of these on my motorcycle. I have another one of these on my 66 Ford. So this can be plugged in and left alone. This thing puts out 900 milliamps DC, so 0.9 amps. So that's a trickle charger. It'll switch to like a maintenance mode when it's fully charged, and you can just leave this thing on there. This is the battery charger I use when I actually have something that's worn down. So that's a 10 amp charger and it's automatic. Again, if it's on, it's not plugged in right now, but if it's on, it'll indicate the amps that are flowing into the battery, and when it sees that the amperage has dropped down to a low enough level to tell the electronics that it's charged, it'll shut off automatically. There's another charger over here. This one will do up to 60 amps, so that's a bit of a beefier charger right there, so it'll do the job quicker, but at the expense of kind of beating up on the battery. Okay, but enough of that. Let's show you these tests that I promised I would show you before we reach our 25-minute time limit on our camera. All right, because I'm going to be actually testing a battery, I'm pulling out my safety glasses here and putting them on. So the first thing I'm going to do is set my meter to DC volts. DC volts would be the setting with the straight line, not the sine wave right there. That's AC volts. Notice my meter says DC as well. If I set it wrong, it tells me. So DC volts. First thing we're going to do is look at open circuit voltage on this battery. So red lead to positive, black lead to negative. You know, and it would help if I put the meter where you could see it, wouldn't it? There you go, 12.46. Oh, we're right on the edge. I'm going to do a heavy load test on this. We'll see if it'll pass. And then we'll try this battery here. Another battery to try. This one tests 12.35. All right, we're going to cheat on this one, but don't be surprised if it fails. So This battery came with my boat. It's actually not a deep cycle battery. It's an SLI battery, so it's really not the right application. And it stayed in the boat for a year and wasn't charged. I brought it in and it was down to like 3 volts, so I didn't think it would come back to life at all, but it seems to have. So, as long as I have my meter set up, I know this one's kind of dirty. I'm going to put my black lead on negative here. I'm going to take my red meter lead and I'm just going to run it along the case. And it's reading 2.4 volts there. I move over here. 4. Move over here. 9. I'm getting a 9 volt reading across the top of this battery. I'm not even touching the other terminal. If I go back here, I got nothing. I've got millivolts, so it's clean back here, but it's dirty over here. So over here by the cell caps where the electrolyte can come out, this battery needs to be cleaned. Alright, as long as I have my multimeter here, I can give you a quick demonstration on how you would do a parasitic draw test. You would start by pulling the red lead out and moving it over here to the amp jack. Again, this isn't going to read anything because I'm not actually connected to anything. I'm going to switch this over to amps. Set the meter up. You would loosen your negative connection. And I apologize, both of these cables are red. I had 2 positive cables hanging around. I didn't have a black one. And they're not connected to anything either, so there's not going to be a draw here. But basically you would do this. Take the alligator lead off my black meter lead. I would sneak that under the cable connection, so I'm touching the battery post. I would connect the other one to the actual battery terminal. And I've now put my meter in series. So the red lead is connected to the negative battery cable, the black lead's connected to the post, and that's a parasitic draw test right there. If there was something drawing, we would have seen it on the meter. In this case, if there was something drawing, I would have been concerned. Okay, and now last but not least, a heavy load test. So, there's my load tester. So, Chicago Electric Power Tools, I think you know where those come from. This was purchased at Harbor Freight. It's a great little inexpensive tester. It's certainly not as nice as something that is meant to be used in a professional shop. It's certainly not a snap-on, and it never will be. But you'll get the idea. So notice I connected my red clamp, my red alligator clamp. It's kind of tricky to try to get this all in the shot. So my red clamp is connected there. Here comes the black one. Try to do this so it's not in the view of the tester. Okay, you notice my voltmeter comes up and reads, so it's reading 12.5-ish. Alright, my ammeter's not reading anything because I'm not drawing current yet. As I turn this knob, this is known as a carbon pile tester. It actually is screwing discs of carbon into each other, and the further you turn it, the less resistance, so the more current flows. Now this battery, 650 cold cranking amps, so 325 is what I want to turn this up to, and we're going to watch. We'll see what we get. If I have a bad connection, I may get a spark at the battery terminal, so we'll see. Okay, starting to flow some current. That's up at 325. This tester actually has a timer in it, and it beeps when you've reached about 10 seconds, but a true heavy load test is 15. So notice we're still up around 10 volts. That battery passed. That's an okay battery. This battery was in my Ford Taurus when I got it. I didn't know the date of the battery, and I didn't really trust it, and since my daughter drives that car, I just changed it out of preventive maintenance. I put a new battery in there. So I think we're about out of time on this video because the camera shuts off right in the 25 to 26 minute range, so we're going to call this video done. So Hopefully you guys enjoyed this video and hope you learned something. I'm not going to test the other battery there because we're going to be out of time here in a second. But those are some of the battery tests that we need to be concerned with. A load test, an open circuit voltage test, and a parasitic draw test. All right, bye for now.